because what I'm going to talk about is food. And you're going to get it from food, believe it or not. So what we're going to do is we're going to pretend what we're going to say is we're going to boil and we're going to make a little bit of pasta. So we need to have a couple pots on the stove. One of them is going to have some water in it, and one of them is going to have tomato sauce, you know, some pasta. And you're going to turn on the heat and watch what happens. Now this is an experiment. This is life experience. Just ask any most of the ladies who do cooking. Because you have two different reactions going on, don't we? We have water that's boiling away, and then you have the pasta sauce, which doesn't do that, does it? What does it do?
Bubbles.
Blah, 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 and then, like, if you don't put the lid on, it's all over the stove, somebody's yelling, things are going on. Okay. Why? What is the difference? Now, I know from an experiment which you should not attempt, you cannot boil tomatoes if you take the water out. You can use your imagination on that, because tomatoes won't boil. So, what's boiling? It's the water. It's the water that's actually boiling, even in the tomato sauce. It's the water. But something changed the water. What changed the water? The tomatoes actually changed the water. It made one much thicker. The viscosity increased. And there is actually a third type. And do not attempt this experiment even with adult supervision. And that's to boil peanut butter. Because the cover isn't going to matter. It's going to, and there's going to be peanut butter on the ceiling and on the floor and everywhere. Okay? And there is those three kinds of lavas which actually make three different kinds of volcanoes. The water is Hawaiian volcanoes. The pasta sauce is Mount St. Helens style volcanoes, or stratovolcanoes located in the Cascade Range all around the Ring of Fire. And the third kind, though rare, do exist. Anybody want to guess? Peanut butter. Thinking peanut butter here. Volcano. Anybody? No? Give up? Where there's bears. Yellowstone. Okay? So, what makes the difference? Now, we have the three kinds of lava, but what really, truly makes the difference? What is the peanuts and what is the tomatoes and the magmas that change it? The answer is silica. That's as simple as that. Silica. How much there is in the magmas inside the volcanoes. And what changes the silica? Three things. Location, location, location. Got all three of them? Here in Hawaii, we are in the middle of a giant plate, but our plate is very thin. And the magmas are coming from very deep inside of the earth through a hot spot conduit which rises up, and there's very little crustal material. And that's where the silica comes from, is in the crustal material. And since we have so little here, our silica content is very low. 50, 52%, 53%, something like that. Now, in the Ring of Fire volcanoes like Mount St. Helens, Mount Rainier, and those, you are in the location where two plates, the Pacific plate, the North American plate, whatever, and they're sliding one underneath the other into the mantle. Now, the mantle is closer from the crust, and it also has old crustal material mixed into the magmas within it. And that's where the source of the lavas are coming from. So your silica content now has been raised up to about 65%. And to show you how powerful the continental material has on it, the case of Yellowstone is a hotspot volcano like Hawaii, but its magma chamber is inside of a continent. It's the heart of the continent that's over 40 miles thick. So it's surrounded by and interacting with all of the crustal material that makes its way into the magma chamber, raising the silica content to 75%. So in each case, you're raising the level of viscosity. And because you raise the level of viscosity, and just like the tomato sauce and the peanut butter, the gas can't escape. So what it does, It makes huge bubbles to build up enough pressure to escape to the surface. And that's the difference